Hey class, welcome to Chapter 8, Lesson 5, which is all about graphing quadratics using factored form, which again is factored form, also known as intercept form. Here's your warm-up. I want you to graph this. I don't want you to graph this. Do not graph this. And go ahead and solve for all the key parts algebraically based on this. This will be great practice for your quiz next week. Here are the learning targets for this lesson. Please make sure you're writing them down. Words like finding the zero and graphing them are going to be important things as we use this intercept form or factored form. So again, just going back to our keynotes, this whole unit is about quadratics. So it's these graphs that go down and up and down. There are different forms. Today we're looking at intercept form. I've already called it factored form. They're both kind of the same thing. So in this case, we have y equals a times the binomial x minus p times the binomial x minus q. As a reminder, the parent graph is y equals x squared, so it's this one that goes down and comes back up. And the big thing down here are these three letters. A is the direction and the steepness, just like how ax squared plus bx plus c was. So if a is positive, it's going to go up. If a is negative, it's going to go down. P is the first x-intercept, so that would be like the first one here. And then Q is the second x-intercept. There's a lot of extra notes here. You don't necessarily need to write them down. Again, we're not doing vertex form this year. You'll re-hit that in the future. But in this lesson, we are really focused on intercept form. And this gives a good visual of what it is. That axis of symmetry, another way to find it is by using this equation, x minus p plus q over 2. So you're taking those two x-intercepts and you're dividing them by 2. Essentially, you're just averaging them to find the middle. One thing to make note of is that these p's and q's, if there's the negative here, then you take it as is. But if this was a positive, then you have to flip it to a negative. We'll show you what that means like in just a second. All right, so for this problem, it says graphing this one using this form. So a couple things we know right away. Our a value is negative. Therefore, this is going to be a decreasing parabola. X plus 1 is one of our intercepts. X minus 5 is our other intercept. So when we're finding these intercepts, we can think, all right, well, if it's the minus, then it's directly that. So for this first one here, we have 5, 0 is one of our intercept points. And for our other one, we have negative 1, 0. So when we're talking about this one, we have negative 1 and 5 as our two x-intercepts. So we would need to go to negative 1 and 5 and make some dots. Dot at negative 1 and a dot at positive 5. We know this is going to be negative. There's a few other things we can do to identify more pieces with our graph as well. One thing you can do is you can multiply P and Q to get your C value, to get your y-intercept. So with this one, we'd have 1 times negative 5 times the negative 1 here would be positive 5. So negative 1 times positive 1 times negative 5 would be positive 5. So I need to write my y-intercept right here. And then I would need to find my vertex. Now, my vertex occurs at my x equals, again, p plus q. The x value of my vertex is simply p plus q over 2, which for this one is plus 5 over 2, which would be 4 over 2, which means the middle of my graph exists at 2. This should make sense because 2 is 3 off of 5 and also 3 off of negative 1. So now I'm just going to plug 2 into this equation to figure out what is my y value. So I can go negative binomial 2 plus 1 times the binomial 2 minus 5. This will give me 3, a negative, and a negative 3, all being multiplied by each other. So negative 3 times negative 3 would be positive 9. So my vertex occurs at 2, 9. Looking on this graph, 9 is going to be just outside of our graphed amount. So go over 2 up to 9, which would be up here. And then I'd be able to draw these through. Okay. Again, recapping. This is a lot of steps, so it's important that we do recap, say what we did. First thing we did is when we found our x-intercepts by solving these each to 0. So x minus 5 equals 0. That would make 5 makes this 0. And negative 1 makes this one 0. Because this is a negative a value, it is a decreasing one. And then our value for our vertex is found by adding our two values together, p and q, and averaging them to get our x value, and then we plug that into our equation to find our y value. For our next one here, we already know a few things about this. We know that our y-intercept is negative 8, so we know that negative 8 is one of our pieces. We also know that 2 is our a value, so it's going to be increasing. So again, our y-intercept is 0, 8, and we know it's increasing. We could factor this. Again, these both can be divided by 2. So therefore, we could factor this into 2 times x squared minus 4. As we've seen before, x squared minus 4, because it's a difference of squares, we can factor this one some more. And this would become x minus 2 times x plus 2, still having our 2 in front. And now we see this is clearly factored in our vertex form. So as we look at this one, we'd be able to say, well, our points would be 2 and negative 2 for our intercepts. Our y-intercept would be negative 8. And then when we figure out our vertex, we would simply need to plug in what's in between both of those. Now, the nice thing about 2 and negative 2, what's directly between those is 0, because 2 plus negative 2 is 0, and then dividing that by 2 is 0. So this one is going to be a little bit easier as we go to graph it. 1 dot at negative 2, 1 dot at positive 2, and a dot down here at negative 8 for our vertex. It is positive, so this is going up both ways. Make sure when you graph it, you're truly crossing your y-intercept there, or your x-intercept there. That would be helpful. All right, we've talked about this a little bit already, but if we're going to do finding the zeros, remember zeros are also known as roots or solutions. So if you're going to find the 0, you simply need to make this thing equal to 0. And technically, you guys have already done this because this is what we did last chapter when we were solving equations. We know that 0 times anything is 0, so we can set both of these equal to 0. And we'd be able to solve for x equals 1 or x equals negative 2. What this means is that we would have one of our intercepts at 1, 0 and one of our intercepts at negative 2, 0. Additionally, because we have an a value in front that is positive, it's not a negative out front, it's a positive, and it'd be positive 1, we would know that our graph would need to look something like this. Again, this is just a rough sketch. But one of our points would be here at 1, 0. Another point would be here at negative 2, 0. And this would be an increasing parabola. So it looks something like that. Again, that's just a rough sketch. But we know these things are increasing because there's a positive here. And we have our two x-intercepts by solving for the zeros, or the roots, or the solutions of this function. Our last two examples here, I'm going to show you guys how to do them in just a second. I'm just going to do all the work and you can come back and see how it looks. But again, this is not giving you a graph. You're just trying to find the zeros. But you'll notice if you're finding the zeros, this is just like what we did last unit. We are factoring, or we're finishing the factoring, and then we're getting all of our values n equals 0. So I'm going to pause this right now. I'm going to add in the answers, and then we'll come back and review them in just a second. All right, so I've shown how to do these, and I'm just going to talk through them. This first one, we factor out the greatest common factor of negative 2 from all three. And then we factored x squared plus 5x plus 6. This factors into x plus 2 times x plus 3. We can set each of these binomials equal to 0. And we would get x equals negative 2. So our first intercept for this one is negative 2, 0. And our second intercept, or 0, for this one would be negative 3, 0. For b, we noticed we had a difference of squares, so we were able to break this apart. X times x is x squared. Negative 4 times 4 is negative 16. Again, these things would have canceled out in the middle. And now we have three binomials, which is completely fine. And this one we get 3 zeros for answers. There is one more problem here. Again, same type of thing. You'd want to first factor this. In this case, this one is h of x equals 0, so it'd be x and x. We need to have a negative 3 and a positive 1. So in this case, our intercepts would be at negative 1, 0, and 3, 0. We also know that this one has a y-intercept of negative 3, and it would be an increasing piece. We would still have to figure out our vertex. Our vertex again occurs at, when we average these two, so negative 1 plus 3 divided by 2 would be 2 divided by 2, which is just 1. So it's our x value of our symmetry is 1. When we plug 1 in for all this, we'd have 1 plus 1 times 1 minus 3, meaning we would have 2 times negative 2. So our answer would be negative 4 for our y value. So then we just have to graph all these. So give me 1 second to graph these. So we get those graphed once we have all those points marked out. Again, talking through where we got some of our different things. Our y-intercept is negative 3, so that's where we got our y-intercept to be negative 3. Our two x-intercepts were negative 1, 0 and 3, 0 by solving these both for 0. Our vertex is given by first averaging our intercepts and then plugging that number back into our equation. And we got a value of 1, negative 4, which is why I went over 1 down 4. Again, this is positive and increasing because it's x squared. You guys do have a homework set. Hope it goes well. If you need any help, just let me know.